So in this topology, okay, let me put it here. So DMVPN lab by Quinet. This is the blank lab, completely blank lab, okay. And let me make it okay. And I can just use these as well if I want to make it a little bit higher, so I can make that. Let me use that. Okay, it's too long. 24. Okay. So this is the DMVPN lab. Hold on, guys. Give me 1 second. Okay. So this ISP router, we have to configure these public IP addresses. So let me start with the ISP router first. This is my ISP router. So on this ISP router, I will do the all public interface configuration. So let me go open. I believe some issue with the internet. It's unstable for some reason, but let me check if I can make it happen. Okay, now it's working. So I'll go in the host name and make as a internet ISP. Something goes wrong. Okay. And do show IP interface brief. And I will assign the IP address. This is the gig 0 by 0, 203.0.0.13.1. So interface gig 0 by 0, IP address 203.0.113.1 I'll use here. Okay. This is going to be all one here. Okay. And 255.255.0. And I'll use no shut. So this is the one interface. On this, I will use 14.1. Okay. So I will just go 0 by 1. And then I will just use 14.1 here. 14.1 and no shut. Then I'll go here and 0 by 2, 15.1. Hold on, guys. 0 by 2. And I'm going to use the 15.1, no shut. And then I will go in gig 0 by 3. Gig 0 by 3. And it is going to be 16.1. No shut. Okay, undo right. That's all. So this is my ISP core, right? So I need to build the underlay connectivity. So I'm just assigning the IP schema, and then I will make sure I have the first underlay. Then we'll try to build the IPsec, GRE tunnel between the branches. This is the one thing, right? I have done. Now I'll go in the hub router. Hub router, I need to create two things. I will create one of the tunnel, and first I'll create my one of the router, and I'll give the default route pointing to this ISP. Every router has the default route pointing to this router, so they can make the underlay connectivity. So I will go here, and this is my interface gig 0 by 0. So interface gig 0 by 0, and IP address is going to be my 203.10.10. Sorry, 203.0.213.255.255.255.0. No shit. And I will give IP route 0 dot, sorry, 0 dot 0 dot 0, 0 dot 0 dot 0, 2030.113.1. That's all. Do right. So I'm pointing the default route here. Now I'll go in the spoke 1. Spoke 1, I'll go and I will configure host name. I didn't change the host name. Let me change the host name as well now. Here. Hub site. Okay. This is going to be spoke 1. do show interface is going to be my gig 0 by 1. IP address is going to be 203.0.114.2.2. No shit. Let me try to ping my ISP side. It is pinging or not. So I'll hold on. Gig 0 by 1. It's not pinging. Why? Gig 0 by 1 203.0.14.1. Check guys, show IP interface brief should be reachable. Okay, so this is fine. This link is connected on here to here, ISP. Let me check here as well. Okay, that's fine. What is the problem then? 2030.114.1 self is reachable and 2. Yeah, it's reachable now. It was taking might be time. So let me go again here and try to ping. Yeah, it is reachable. So I will add one of the static route here. Pointing toward 203.0.114.1. And now I need to ping my hub location. This is my NVMe address. This is my NVMe address. 2030.13.13.1. So I will go here and ping 203.0.113.2. And it should be reachable. Because this is must be going via this one and it should be reachable. To show IP interface brief. Yeah, it should be reachable because do show IP route. Okay, I forgot to put the static route here, no? So for some reason, IP route, there is no default route available. So let me put default route here as well. 2030.113.1. Now let me try. Should be reachable. I put it that address. Do show run pipe include IP route. Hold on, guys. I believe there is some issue. Let me ping this IP address. It is reachable or not. Okay, so this is not reachable. And this is the region. So why it's not reachable? Gig 0 by 0. Let me check. We have this IP address and ISP side. This is the IP address. So gig 0 by 0. Yeah, it's absolutely fine IP address. Yeah, it is also 2030.213. 2030. Okay, 213, not it's 113. Sorry, it's my bad. There is a mistake now. I have done the mistake. Hub side. Sorry, guys. This IP should be not 213. It should be 113. This is the wrong subnet. Okay. Now let me try to ping again. Ping this IP address. .1 first. Yeah, now reachable. Now if I go in the spoke, should be reachable. And it's reachable. So you have the underlay reachability from this to this. Now similarly, I have to do the underlay reachability from this location as well. Spoke to as well. So I'll go spoke to. Simply I will just do the configuration. So I will go here and host name is going to be my spoke 1. do show IP interface brief, and I will assign the IP address, that is a gig0/2, gig0/2, and IP address is going to be, this time is going to be 203.0.15, 203.0.115.255.255.255.0. No shit. I'll first ping point to point, whether it's pinging or not. Then I'll go for the next step, because if it's not pinging, then I have to troubleshoot. Sometime make mistake as well. Should be reachable first. One is configured on the ISP side. So IP interface brief. Let me check. Yeah, 0/2. 0/2. And here also should be on 0/2 now. 0/2. Let me check on the spoke 2. Okay, that's correct. We'll try one more time. It will ping. Sometimes take a time. Yeah, it's pinging. You can see. So now it's pinging. So now I can do the IP route configuration. I will give the static default route pointing to the this desktop, and then I will ping my hub as well. And I'll make sure I have the under reachability with the hub. So I can go here, do ping 203.0.113.1 should be reachable. Yeah, it's reachable, then I'll do right. I have the underlay with the spoke 2 as well. Now it's time to spoke 3, and then we can go for the next step. So I will go here and config t host name is going to be my spoke 3, and do show IP interface brief. And interface, I'll go and configure gig0/3. So gig0/3, and IP address is going to be my 203.16.2, 203.0.116.2, 255.255.255.0. No shit. I'll wait for a while, and I need to ping point to point. Meanwhile, let me check. Show IP route. I'll give the another static route as well. 203.0.116.1, and do right. Let me try to ping whether my gateway is reachable or not. So I will first go and try to ping this address. If it is reachable, then I'll go and ping my hub location. It's not reachable. Yeah, it's reachable. So now I'll ping my 113.1, and should be also reachable now. Yeah, wait. So guys, we build the underlay connectivity. This is the underlay connectivity, means my all public IP address, which is hosted in the different branch, they able to reach. This is the very first step. If you don't have the underlay reachability, you cannot form the overlay reachability. So now we have to create tunnel interface. We have to create the configurations for the phase 1. We'll do phase 1, then phase 2, then phase 3. So I will try to complete the phase 1 today. If not possible, we'll have another master class on the phase 2 and phase 3. But let's create the tunnel interface. I'll go on the hub locations and I'll create the tunnel interface. I'll go here, interface tunnel. I'll use the tunnel 0, and IP address is going to be 10. Hold on. 0.0.1 to 55.255.255.0. So show run, let me show run interface tunnel 0. I will copy this configuration. Okay. I will go in the spoke 1, config t, and I will paste it here. This is going to be .2. Okay. This is going to be .2 only. I'll go here and I will paste here. This is going to be hold on. This is going to be .3. Okay. I'll go here, paste it. Do show IP interface brief. Now we'll check it. We have .4. Okay. Tunnel is required. Do show IP interface brief. This is .3. That is fine. I'll go here. Do show IP interface brief. This is my page. Means .2. That is also fine. And here is a .1. So you have to get a tunnel interface. Now we have to understand. Right now, if I'm going on the any locations and try to pick tunnel, it's not going to build a tunnel. Let me try. If I'm in this here, let me show you. If I am trying to ping my 10.0.0.2 tunnel, which is this IP address, from the spoke, means from hub to a spoke, it is not going to ping as of now. It's not pinging because we not have the DMVPN tunnel, means GRE tunnel or mGRE tunnel. So we have to build the tunnel. So how the tunnel is going to build? So to build a tunnel, we have to use the official certification guide. I'll show you how you can refer and create the tunnel, and I'll explain each and every command informations as well. So if you go in the dynamic tunnels, so the same step, whatever I cover, they written here why it is going to use. This is GRE tunnel and all, NHRP and all. Let's understand step by step. This NHRP already explained, but how the phase one tunnel is going to be created. This is the DMP phase one. This is the phase two and three. The phase two and phase three are same. Only the difference is in phase three you can do the network summarization, and phase three it's going to be always a spoke to spoke. There is no hub dependency is going to be there. So if I want to create my phase one tunnel, so you just have to follow this official documentation if you want to create, and then we have to understand each and every line by line configuration meaning. Okay, so where is the configurations? Give me 1 second, guys. Okay, see, this is the phase one configurations. Okay, so in phase one configuration, if you see here, I created tunnel interface, I give the IP address. Now ignore this bandwidth command. I already explained what is the MTU command and what is the adjust MSS command. These things you know that. Just follow this mapping, not this. This is the hub locations, okay? And then you have to create the NHRP network ID. This should be unique. Network ID is going to be unique for your all configurations. And then after you can just create tunnel in source interface, tunnel mode GRE. This all is going to be there. And based on that only you can do the all configurations. So if you want to build the phase one configurations, you have to adjust the TCP, adjust MSS, and then you have to create the MTU. Then you have to go and give the NHRP mapping, that is a multicast dynamic is going to be there. And then after basically you have to go and give the mGRE as a tunnel mode. And this is a tunnel source interface. But in a spoke, you just have to follow this one. Again, your bandwidth is going to be there, IP is going to be there, but you have to do this NHRP mapping. Means your public tunnel means public IP address with the private tunnel IP address. And you have to give the multicast address. This is your NBMA address. This network ID should be same NHRP. If you can use the NHRP authentication key as well. I'll show you how the authentication key is going to be there. Might be it's not covered here, but might be in my slide it's going to be there. Let me show you. Here is the configuration. This is a phase two. Phase one is there. So we can use the additional command next stop cell PIGRP. Why it is going to use, I'll explain that. But here you can see there is a NHRP authentication command. We can use that authentication as well. Okay. And TCP adjust MS. So let's do that, how it is going to happen for the phase one, and then we can do for the other configurations. So show run interface tunnel 0. I will explain each and every configuration meaning of this hub locations. So I'm in the interface tunnel 0. The very first thing, IP MTU, let's suppose I'm giving the 1400. Then I will give the second step, IP TCP adjust MSS is going to be 1360. This is the second command. Then after, what is next? In next command, I will do the NHRP mapping. So in this case, this is my hub location. So it is going to be do the dynamic mapping. So I will use the IP NHRP multicast dynamic. Hold on, IP NHRP. Okay, so I use a map now. Sorry, I forgot map. Multicast dynamic. Okay, this command I need to do. This is going to give the dynamic mapping. I will explain later on how it is going to happen, dynamic mapping. I will show that dynamic mapping as well. Now I want to give the authentication key. As I mentioned that authentication key also is very important to secure my NHRP is going to be authentication. So key should be same both side. If it is not same, it is not going to map your NHRP. Now what next? After that, you have to give the unique NHRP network ID. NHRP network ID. And this can be any number from this range. I can use the 1, let's suppose. And then you have to give the, what is a tunnel source? Tunnel source is your public IP interface address. In that case, we are going to use this as a source. This 0 by 0. 0 by 0. Okay. This is going to my source. Okay. Now, after that, what is my tunnel mode? I will make this tunnel mode as a mGRE. So mode is a GRE, multi-point is going to as a mGRE. And you can want to secure this tunnel, then you can keep the tunnel key. Means if the key is going to match on both sides, then only it is going to be make the tunnel configuration. That's all. So this is my hub location, and you can just write this configuration. Now, how I can create the configuration for the spoke locations? It's going to be similar, but few changes you have to make. Let me show you what changes you have to make. So show run. Give me 1 second, guys. Show run interface tunnel 0. This is my hub location configuration. I'll copy this configuration. Text. I'll go here and I'll paste this configuration. In hub locations, right? This or IP already assigned, that is not needed. IP redirect is going to be there, not needed. But you require this authentication also needed on the hub side. I mean the spoke side. This is required, mandatory, should match. This network ID should match. Tunnel key should be match. MSS should match. These all should match. But tunnel mode is not required the multi-GRE in the spoke side. This command should replace with the tunnel destinations. And this destination address is going to be your public IP address of this one in every spoke sites. So what is that? 203. Let me go it here and give that. This needs to be replaced. Into that. Hold on, guys. So I will go here, and this is going to my destination is 203.0.113.2. This is my tunnel destinations. Clear? Key is also going to be there. So just only this change is going to happen. Only one change is going to happen. In addition of that, two more changes you have to do that. That is only under the NHRP. And what is that? You have to do the manual mapping for the NHRP. In that, you have to use the IP NHRP, and you have to give the map multicast, and this is going to be your NVMe address of the hub location. Okay, this is the one command. The second command you have to use the, again, your NHRP mapping, but this is going with the your tunnel IP address of the hub locations. Along with that, you have to give their NVMe address, means their public IP address. Means this mapping is basically I'm doing to whom you make the NHRP communications. So that is my tunnel address 10.0.0.1, and that is the corresponding to my public IP address. Now one more command I need to add. What is my server IP address? Means NHRP server. That is the IP NHRP, and that is going to be my NHS address, which is NHS 10.0.0.1. This is my final configurations. This is my final configuration, which is going to require in every tunnel. Let me check quickly with the configuration. It's matching or not. I will explain these two commands. Next hop self EHRP 100 and split horizon. What does that mean? But you can see here, MTU is there, tunnel IP is there. You have to give the authentication. You have to give the mapping. That is the IP NHRP map that is required. That is IP NHRP map that is going to also required. Network ID is also required. We are using network ID. Yes, we are using network ID. And adjust MSS already be done, and that's the tunnel destination. So I believe we are good. So now if I just copy this configurations, and I can paste this configuration on my all the routers. Same means I'll go in the spoke 1 and I'll paste it here. That's all. This is the very first router, okay? And then after what I can do that, I'll go in the spoke 2. The same configuration is going to be there because already we assigned the IP address. So I'll just copy these configurations. This is also done. And then I'll go here also. And this is also going to be done. Now, we have to check whether my DMVPN tunnel is there up or not. DMVPN. So something went wrong. Show DMVPN. Yeah, it's trying to create a tunnel, but there's no tunnel. Show DMVPN. It's also not initiated. Okay. So this is the static, but for some reason the tunnel is not created. So we need to troubleshoot why tunnel is not created. So show run interface tunnel 0. IP authentications, that is going to be there. Let me just quickly check with my this book. IP NHRP map, tunnel source is going to be there. We can quickly have a look. What is the wrong with this tunnel? So we have the IP address, and then we have the IP NHRP, that is fine. We have the NHRP authentication key, that is also fine. That is a tunnel mode, is this one. Source is this one, that's not wrong. Okay, I found the, see, the wrong is this tunnel source need to be changed. For a spoke one, I got the problem. I just copy and paste. This tunnel source should be this one, 0 by 1. This is the problem. Okay, guys. So I need to change the source, and that's why it's not coming up. So this is going to be tunnel source, this one. Okay. Now I'll go here and show run tunnel interface 0. This tunnel source should be 0 by 2, not 0 by 0. So I just copy paste and make the mistake. So interface tunnel 0. This is going to be my 0 by 2. Okay, so this is the wrong. And if I go here, show run interface tunnel 0 also. Interface tunnel 0. This is going to my 3. Let me check here, 3. Now let me check here again. Show DMVPN. Yeah, you can see these all tunnel come up. But very important, guys, let me explain. Do right. Let me do right. We end with the last sections. Okay. So my tunnel is came up, right? And after that, if you see here, this tunnel came up. These all tunnels showing dynamic because it's a mGRE tunnel. So it's build the dynamic tunnels. But in the spoke, it is going to be static tunnel. Every spoke, it is going to be static tunnel. DMVPN. So this is going to build the static tunnel. This is the S. But in phase 2 and phase 3, it is going to be dynamic also. It is not going to be static, but here it's a complete static because we have make the static DMVPN. This is the static also. And if you go here and run the command, show DMVPN, it also going to be static tunnel. Clear? So till here we build the everything a static tunnel. Now what next, guys? Next is if I go in the hub and try to ping my these addresses should be reachable now. Because they build the tunnel, so all tunnel address should be reachable. See, 2 is reachable, 3 is reachable, 4 is reachable. But now if I'll create loopback address on the every routers, if I create the loopback address, let's suppose I go and create the loopback address and I want to make the as a LAN reachability. Interface loopback 1, IP address 1.1.1, okay, 255, 255, 255, 255, and I'll go and configure a tunnel interface loopback 2, IP address 2.2.2.2, 255, 255, 255, 255. Sorry. This is done. I'll go here and create another interface loopback 3. IP address 3.3.3.3 255 255 255 255.255. This is also done. Show IP interface brief. This is also done. And I'll go here and create tunnel interface loopback 4, and I create this IP 4.4.4.4. So 255, 255, 255, 255. So do right. I created loopback. Now I want to make the loopback reachability. It is not possible. Tunnel are reachable, but the loopback are not reachable. So to make them reachable, what I have to do that over mGRE tunnel or GRE tunnel, we have to build the any kind of the routing protocols. And for that, I'm going to use the EIGRP routing protocol. And this EIGRP routing protocol is going to be give that variations to advertise my loopback addresses from one location to another location. So if I go in from the hub location and I try to ping loopback 2.2.2, it's not going to ping because this loopback routing doesn't have, means hub doesn't know about the 2.2.2 in routing table. So if it is not going to know, then how it is going to make the reachability? It's absolutely not possible, guys. So if you check here, show IP route, you are not going to find this 2.2 is available. So I can just go and enable the router. OSPF also can enable, and I can use the network 1.1.1, 0.0.0.0, and also include the tunnel interface 10.0.0.0, 0.0.255, done, and show run section EIGRP. I will copy and paste for the routers. All the loopback is going to be changed. So this, hold on, I lose that access. What happened? Sorry guys, I believe I lose that connectivity. Okay, I believe I'm fine. I can, okay. So for this, I can go here. Let me copy it again from here. Okay. I will copy it here. This is going to be changed. For the spoke 2, I'll just copy this one and paste it here. Spoke 1 basically. And I'll paste it here. Okay. And for the spoke 2, it is going to be 3.3.3.3. See, we have the EIGRP neighborship. Oh, I lose this connectivity. Okay. So I'll go again in the router 2, spoke 2. I need to paste these configurations. So I will go here and paste it. And this I'm doing also EIGRP neighborship. I'm losing the connectivity again, but I will try my best to complete this lab. Let me try this one. And okay. This is also done, guys. So we have the EIG. If you go in the hub locations now, and you go in the hub router, you see show IP EIGRP neighbor. We have the 3 neighbors. So now if you check show IP route, we have the all loopback addresses are available. But still, if I try to ping 1.1.1, extremely sorry, there is some internet issue. I never expected this is going to be happen in the last moment, but yes, it is having, so I cannot do anything. So if I'm going to ping 2.2 with source 1.1.1, it is reachable. But the problem is, if I'm in the spoke 3 now, and if I try to reach my locations for any hub, right, like any spoke site, means if I'm there, And if I try to reach my, let's suppose I want to ping one dot, sorry, not hub. I want to ping the 2.2.2. With the source here, we created the 4.4.4. It is not going to ping. Why it is not going to ping? Because there are the EHRP default behavior. By default, split horizon rule is going to be enabled, where if you are learning any route, if you go and understand what is the split horizon rule in EHRP, split horizon rule in EHRP. So this is going to tell you split horizon rule prevent the router from advertise the route back to the same interface. So see what is happening. You're getting a route from this EHRP neighbor. You're trying to advertise the same route on the same interface because you need to advertise the route to the spoke from the same EHRP interface from where a route is learning. So by the help of the split horizon rule, this route is going to be create an issue. If you go in the spoke 1, let me go in the spoke 1. And if you check show IP route, you're not getting route for the loop back 3 and 4. Why? Because they are advertising to the hub location, but due to the split horizon rule, it is not advertising back to spoke 1. And similarly, if you go the spoke 2, it will not get the 2.2 loop back on the spoke 2. If you go in the spoke 2 now, and you check the routing table. So you just check the routing table, show IP route. You are not going to get this route. 2.2 is not available. So to avoid this behavior of the IGRP, we have to go in the hub locations and because we want to get this route. So I will go here on tunnel interface tunnel 0 and no, and there is a command known as the, what was the command? IP split horizon, no, let me go here, no IP is split horizon EIGRP, and we are using the 100. The moment you do that, now you see you are must be start getting the your remote lover. See, and now if I'm going in for the spoke route and try to ping this 4.4 with the source 1.1.1, it should be reachable. Sorry, source should be 2.2.2. So it is reachable. So if you trace this subnet 4.4.4.4 with the source 2.2.2, this will first go in the spoke, and that means first it will go hub and then it is going to the spoke. This is how it is going to happen behavior. Even if you go for the any kind of the site 3 location, and here also you check show IP route, you must start getting the route for the 1.1 and 2.2 and the 3.3. But if you're trying to trace here this 2 subnet with the source 4.4.4.4, it is going to be via hub. So all communication must be going via the hub. Let me show you the live trace. See, this go 10.0.0.1. What is this one? This is my hub location, and this is my further spoke location. That is a spoke 3. And if I'm doing the trace from the spoke 3, it is going the first hub, and then it's going to the spoke 2. So this is how it is going to happen. So this is the meaning of the command. Sometime in the interview, when you're going for the DMVPN, they will ask what is the meaning of the split horizon. And no IP next hop self means you are not, it is not recommended. Always you have to use, but if it is there, what happened when we're going to use the IGRP, it will send the router itself as a next hop as a that route. So you don't require in new iOS, it is going to be supported. So if you want to know more about that, so the meaning of this is means the hub router is not going to set the next hop for that particular route. So this command noise by 100 not valid cisco HTTP command, right? However, IP next hop self is a valid command. So earlier it was the old command, but still it is going to be used in the DMVPN. But now it is not recommended. That's why I didn't use that one. It is not going to create any problem. Even if you want to ignore that, you can ignore that. But this command is very important, guys. Split horizon. If this is not going to use, your router is not going to receive the route. Even your HTTP neighborship is up and working. So every router even go for the spoke 2 and you check the EHRP neighborship. Show IP EHRP neighbor. It is going to be showing the hub location. This is spoke 2 also. Show IP EHRP neighbor. It is going to be at the spoke location. You go here. Show IP EIGRP neighbor, it is going to the hub location, sorry. But in the hub locations, show IP as GRB enable, it is going to the my all site, and show DMVPN. This is going to be all dynamic tunnels. And if you check the details, it is going to show all the dynamic tunnels. And if you go for the spoke locations, show DMVPN, it is going to show as a static tunnel. And detail you want to say, you are going to get more detail also from here. So this is a phase 1, guys. And for phase 2 and phase 3, there are 4 new configuration you have to do that. Means there are some minor changes going to happen. Tunnel mode as a multi-point in this phase 2, and phase 3 we have to use the NHRP redirect and shortcut. So I will arrange one more session. It's going to be very long if I'm going to test these all things. So I hope you guys understand at least DMVPN concept. What is IPsec, what is GRE, what is a VPN, what is a GRE over IPsec. Even I will integrate the IPsec over this DMVPN to just make the encryption end to end. So that is going to be a separate session for that one. Okay. So I'm closing the session till here, and please write your feedback, comment. If you really like this session, just share your comments or any feedback, so I can just try to take as a note. And if any improvement is needed, I will try my best in the next lecture. Thank you so much. Have a great day. Bye bye. Take care.